Swayam Prabha. Digital India. Educated India.
Now sigma xx is given by mz by izz minus into y minus y naught, right. Mz we have found before, izz for a given cross section, let us assume the cross section to be rectangular, let us assume the cross section to be rectangular with the following dimensions, this is y, this is z, this is b, this is h. Okay. Now y naught should be the center of the cross section, which means this is the CG of the cross section. You know that for the rectangular section the CG is at half the width and half the height of the cross section, hence this distance is going to be p by 2 and this distance is going to be h by 2. Okay. Now I am measuring y from the center of the cross section. So y naught is 0 from here, y naught is 0 because the origin of the cross section coincides with the center of the cross section. Okay. Now what is izz? Now izz for this cross section is integral y square dy minus h by 2 to h by 2 into dz minus b by 2 to b by 2, right. Okay. So in z I am integrating from this point to this point, the width is the same, so it does not matter how I integrate. Okay. Y square dy is from this end to this end I have to integrate, y square dy I have to integrate from this end to this end. So it is from minus h by 2 to plus h by 2. Okay. The width is remaining constant, so it does not matter how the order of the integration is, what the order of the integration is. So this integrates from minus b by 2 to plus b by 2 along the y direction. So this will be integral minus b by 2 to b by 2 y square by 3 y cube by 3 from minus h by 2 to h by 2 into dz, which will be h cube by 12 into integral dz minus b by 2 to b by 2, which will be nothing but h cube into b by 12. Okay. So izz is, from here you got izz to be bh cube by 12. Okay. So from the previous derivation we got mz to be w by 2 Lx minus x square. Okay. So sigma xx is now given by minus w by 2 to Lx minus x square divided by bh cube by 12 into y. Okay. Now you find that across the depth of the cross section the sigma axis varies linearly. Okay. So across the depth of the cross section the variation of sigma xx is linear, with what happens at the top y is positive, bending moment is also positive. Okay. So the stress has to be negative. Okay. So that is why it is in compression, it is in compression acting like this, and the bottom surface y is negative at the bottom, at this end y is negative, and hence the stress has to be positive. Okay, because the bending moment is positive. Okay. So it varies like this. Okay. Now this is just the sigma xx variation with respect to y, and this point is the CG of the cross section, this is the CG of the cross section. Okay. But what are we interested in? you are interested in where the maximum sigma xx occurs and what is the value of this maximum sigma xx. Maximum sigma xx will occur where the bending moment mg is maximum divided by bhq by 12, and you know that since it is varying linearly, the extreme points is where the maximum occurs. So, the sigma xx is varying linearly, the extremum points is where the maximum stresses occur. So, it will be at h by 2, at h by 2. Okay. We just now saw that mg max is given by WL square by 8, okay, and so this expression becomes into 6 by BH square, right, sigma xx max. Okay. Now, let us do an analysis now. I will rewrite sigma xx max as W 3 by 4 B into L by H the whole square. Okay. Now, the W is force per unit length, right, that is W by definition was integral sigma yy into dz, right, from minus b by 2 to b by 2, that is sigma yy into b was W. So, W by b is sigma yy, right. So, this happens to be sigma yy into 3 by 4 into L by H the whole square. Okay. Typically for a beam, L by H for beams would be greater than 10. Okay. For those beams only whatever we are doing is valid. If the beam is too short or too deep, whatever we are doing is not valid. Okay. So, then you find that sigma xx max is roughly 100 times sigma yy. So, even though the applied stress is sigma yy, the stress resultant, the stress that is developed in the beam because of the application of a sigma yy stress is 100 times more than the applied stress. Okay, that is why it is important to compute what the stress is. It is not equal, just enough to find what is the stress that is applied. Okay, the developed stress can be much more than the applied stress. Okay, this is a thing we will see repeatedly in this course now. Okay, so this is sigma xx.